So here we go, negative exponents. Guess what? Negative exponents are not okay to leave in an answer. If you have a negative exponent, it must be rewritten. A negative exponent will have to go in the denominator. And once it crosses that fraction bar, it becomes positive. The fraction bar is a magical line for exponents. Yeah, recycle it with this guy. Okay, so let's talk about this. This first example, x to the negative fifth, we would rewrite as 1 over x to the fifth. Why? Okay, we cannot leave. Is that a real question, or are you just kind of being, okay, can tell if you're being ornery. Okay, we cannot leave a negative exponent in an answer. So if we have a negative exponent, we have to move it across the fraction bar. Okay, when an exponent travels across the fraction bar, it changes signs. Okay, so there's like this, I mean, over 1, right? Everything can be written over 1. So when we take it across the fraction bar, okay, because of this rule right here, x to a negative power is the same thing as 1 over x to that power. Okay, so here we go. 3m to the negative second. Does 3 have an exponent on it? No, so it stays as 3. No. So this is 3 over m squared. That negative exponent has to go to the denominator. Yep. All right, does negative 7 have an exponent? No. No, so it stays as negative 7. A is raised to the negative fourth, so it will need to move down to the denominator, a to the fourth. And what about b to the third? Is that a positive or a negative? So it stays. I know some of you are kind of freaking out, but it's not a big news thing. That packet of notes that I gave you this morning. Let's go and get that out. Number 4. The things they know what I should do. What do you say? There's a couple different ways that we can approach this problem. Okay, probably the easiest way would be this. What do we do when we multiply with our exponents? Okay, so we have w. What is 7 plus negative 9? So we have w to the negative 2. Huh. So 1 over w squared. Bless you. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3. She's a 4, 5, 6, 7, 8,
I'm
1.
a 3.
Yeah. You're a 2, 3, 4, 5, 6, 7, 8. Okay. You are going to meet your people at whatever number I gave you. 1, 2, 3, 4, 5, 6, 7, 8. And you are going to do problem number 5. Okay, this problem number 5. Where are my tubes?
I know.
Right there with Andrew. 4 is right there. Where? Who else is a 6? Preston, you're gonna be a 6. Holden, go be a 6. That's a 5. Holden, this is 6.
We can tell them we're gonna crush them. Miss Holman, guess what?
What?
Westside's best point guard broke her foot.
I think Avery had to do something with that. I
She
think she
plays
has,
for attack and she lovely foot. But
I think she did.
so, yeah, I knocked her foot. No.
Okay, go ahead and go back to your seats. You'll be back there. Don't worry.
Her name is Jaya. Not you, but Jaya's the.
What's her number? I gotta see first if I'm over. What's your number?
All right, so I'm seeing 20 C cubed over D to the 4th. Okay, so 4 times 5 is 20. When we take C to the 8th and C to the negative 5th, we add those together to be, okay. And then D, we would add to be D to the negative 4th. So 20 C cubed over D to the 4th, that's great. Okay, write that down. Okay. All right, let's go to number 8. Number 8 is a very interesting problem.
I got parentheses.
Mm-hmm.
I know what to do.
What do you need to do, Avery?
So, you need to multiply 8p5 by -2. So it'd be 8p -10.
I agree with the P to the negative 10th, but I do not agree that it stays as 8.
Oh, give me a second. I'm almost there. It will be it's negative 16.
Negative 16.
No, it's
64.
And then you put a 16 over it, and you get a walking positive 16p10.
I agree with over P to the 10th.
Negative 16.
Can
Okay,
I make
and-
a suggestion?
Sure.
Since exponents mean we square them, 8 times -2 would not be -16. 8 times, or that would be, but if we're squaring it, 8 squared is -64.
It is not negative 64.
Is it not?
Hold on. Still not positive 64. Peyton,
I would hope she did.
Okay, I agree that there is a 64, but it's not here.
It's not there.
Never said where it was.
It is 8 to the negative second. Can we have negative exponents?
Where's the two?
No.
At the end of the bracket.
Why did?
They both have to come downstairs. So this is 1 over 64 p to the 10th. Okay, I'm gonna wait for people to stop making noise and I'll explain this again. Okay, this is like 8 to the first, right?
Yeah.
Okay, so power to a power, this becomes 8 to the negative second. Well, if we have a negative exponent, it has to move across the fraction bar, right?
Yeah.
So that 8 to the negative second goes across the fraction bar, and in the denominator, it's now 8 to the positive 2. And 8 to the positive 2 is 64, but it has to come down to the denominator. Okay. So let's do this one right here. Number 9 is very similar. How about you write down what you think it is? Modeling what we just did in number 8. Check in with your elbow partner. All right. Nirvan, what did you get? Do you agree with this?
I disagree.
What do you disagree with?
I think it's. Oh, just kidding. Mine's the same thing. It's just I didn't do the 125.
Okay. Okay. Hey, okay.
Wow.
All right. I would like you to come back to your groups. Maddie, you're a 4, and you're going to do this number 15 with your group.
Oh my god.
Elliot, you going to go to your group? Oh, you have such a far walk. Yeah.
And then that's over 2 and yeah. Wait, yeah, so first it's oh wait, I guess the negative one. And then wait, so then it'd be 5 and 1. No.
Are you gonna do something?
What?
Yeah.
Focus on your group.
I've heard something.
And also this is like
So I don't know why the 5 isn't possible.
then we put that.
Zach, you in our group.
Okay, back to your seats.
Is that right? Yeah, I don't know.
So I like a lot of things
Reagan, you might have been right.
that have happened. And I think we're about to have a really good conversation.
You might
Okay?
have been right.
I really like that people knew that 10 divided by 2 was 5. So I saw the negative 5. I really liked that people, I even heard them say, oh, when we're dividing, we need to subtract our exponent. Well, what's 2 minus 3? -1. Okay, and then you did that here. You said, oh, we need to subtract our exponents. And we have 1 minus -5. Oh, -4. -4 is good. Okay. Actually, no. But it's not -6, it's +6.
Because 2 minus is equal.
Listen. We are taking 1 minus -5. 1 minus -5.
Oh.
Okay. Now, here's my next issue. What's the exponent on 5?
Oh,
Third. One.
1.
No negative.
There's not a negative exponent. -5 gets to stay. N to the 6th gets to stay. And M to the 1st has to go downstairs. Please write out both the work that I showed and the answer. Never mind. Uh-huh. So we take the numerator minus the denominator. So we take 2 minus 3. 1 minus -5. I'm here for it. Well, the M has a negative exponent, so we have to move it to the basement. Okay. So let's come up to 13. 13 is simpler, okay? Let's just go back to a simpler problem, okay? We are dividing, so what do we need to do with our exponents? Okay, we always start with the numerator and then we subtract the denominator's exponent. So what is -2 minus 7? Okay, now for D, we have to take -1 minus -2. Okay, that would be a +1 for our exponent. So we would write D to the 1st, but we wouldn't have to write that first, over C to the 9th. That negative exponent has to be pushed across the fraction bar.
Yeah.
Are you okay with that? You don't think what?
Oh, never mind.
Okay. Okay, let's see. From this chunk of 4, Carter, pick one.
16.
All right, we're gonna look at 16.
The easiest one. That's pretty mad, bro. You want number one?
Hard ones help us learn better than easy ones.
Okay, Maddie, what is 36 divided by 12? Thank you, Maddie. Okay, do you see any X's in the denominator? No, so I'm gonna write X to the -4th and then Y if we subtract our exponents here, it would be 1. So our answer would be 3y to the first over, we have to take that x, since it has a negative exponent, and move it down across, push it down.
Force it down.
Force it down. All of these purple things. Thank you. All right.
Avery.
All right, Avery, I keep hearing your name. Pick one from 20 to 25.
Let's do 25.
Really?
Did I just hear a zero?
You are kidding.
So, plan of attack here. Let's rewrite our numerator, let's rewrite our denominator, and then move forward. Sound good?
Yeah.
Okay, so Avery, in our numerator, what is 6 times 3?
18.
Okay. Reagan, what is b times b to the 5th? Not quite.
6.
Because we have b to the 1st times b to the 5th.
1 times 5.
We have to add our exponents when we multiply.
Yeah, Abby.
Okay. So redemption here, Reagan. What about c cubed times c squared? There we go. Okay. All right. Holden, 5 times 2. Good. Okay. All right. Gavin, b to the 5th times b cubed. And then c to the, everybody?
Yay.
Okay. Wow. If we take 18 divided by 10, that doesn't work out very nice.
8. Just simplify it.
So how about 9 over 5? Okay.
I know.
And then we have b to the negative 2nd and c to the negative 3rd. If I take 6 minus 8, I get negative 2. If I take 5 minus 8, I get negative 3. So I'm going to rewrite this as 9 over 5 b squared and c cubed. They need to be pushed down to the denominator, and their negative exponents become positive. Guess what your homework is?
Page 13.
Page 13.